Evaluate the summation. The sum as I goes from 1 to 52 of I plus 3 times the quantity I squared minus 2. Now in its current form, you cannot find the summation of this. We need to distribute all of these terms together to create an expression with only addition and subtraction. So when you FOIL this, you get the following summation. The sum as I goes from 1 to 52 of I cubed plus 3I squared minus 2I minus 6. The next step is to separate all of this out. We don't want the coefficients next to the i's. We want those outside of the summation. We don't want 4 terms in one summation. We want each term to have its own summation. So that'll look something like this. The sum as I goes from 1 to 52 of I cubed plus 3 times the sum of I squared as I goes from 1 to 52 minus 2 times the sum of I as I goes from 1 to 52 minus the sum as I goes from 1 to 52 of 6. So inside the summations now, there are only I cubed, I squared, I, and a constant. So with this, now we can start using the formulas to simplify these summations and get this summation notation out of here and get something that we can actually work with. And when you use the formulas for the summations, the sum of I cubed from 1 to 52 is the upper bound squared times the upper bound plus 1, which would be 53 squared, all over 4, plus 3 times the sum of I squared as I goes from 1 to 52 is the upper bound times the upper bound plus 1 times 2 times the upper bound plus 1, all over 6. Minus 2 times the sum as I goes from 1 to 52 is the upper bound times the upper bound plus 1 over 2. And the last one, when you're summing a constant, it is the constant times the upper bound. The only thing left to do now is to add up and subtract or combine all of these numbers to get your final answer of 2,040,506. There is the final sum of this original expression from 1 to 52.